Now let's consider another mechanical system. If from the ceiling there is a joint here, and we have a piece of road here, a bar here, and it is connected to a joint, and then there is another bar. So if we have a system like this, how can we visualize how it works? So before introducing the system modeling, I have to have this kind of knowledge at hand. The parameters in the system, we have the bar length. One is 40 centimeters, the other one is 20 centimeters. And another important thing is the inertia matrix, which can be calculated in the formula. So once we have this in mind, I will explain how can we create a simulation system for this kind of mechanical problem. We can click the sim mechanics toolbox, and we can see that there are some groups. One of them is the bodies, often described rigid body. And here we have the body. And in the body, if we specify inertia matrix, like a diagonal, if it is a diagonal matrix, then it describes a road. If it is a rod. If it is described by other kind of matrix, then you can describe different shape of the rigid body. For instance, you can describe this kind of circle by specifying a complicated inertia matrix. Apart from the body, we have different kind of joints. We have translational or rotational, 1 degree of freedom rotational, 2 degree of freedom rotational, 3 degree of freedom, and also we can have a 6 degree of freedom range. We can have different kind of blocks to model the system. So let's see the simulation model I created earlier. R2. This is a block diagram I created myself. First, there is this is a ceiling, we call it ground, should be the same. This is a fixed. Then we have 1 degree of freedom rotational joint. Then there should be a rigid body. We can describe the bars in the pendulum, and then there is another joint and another bar. So we can create the system like this. And the information we have to specify is especially in the bar, we need to specify the mass of the bar, the inertia matrix of the bar, and also the coordinate of the bar, initial coordinate, and the center of gravity. We can select the wall, the coordination, or the other kind of coordinations. So we can specify the information like this. And then we can start simulation of the system. So this is the way it works. We can perform simulation in this way. And if you want to get the animation part, you have to specify in the Simulink menu and go back to configuration parameters. And there is one item for in mechanics. If you double click it, you will have further information about sim mechanics. And there is one important thing is show animation during simulation. You have to click it and then you can visualize the simulation result. And let's see the the 4-bar mechanism. And here we have ground here and ground, and there is a joint, 1 degree of freedom rotational joint, and we have a bar here and another joint and another bar. So we can model the system using make 4 bars, so make a 4-bar program. And then this is the simulated description to the problem. And again, what we need to do is to connect the system together. This is the ground, and this is the joint, and this is the bar, another joint, another bar, joint, and another bar, and joint connected to the ground. So this is a 4-bar system. We do not have to get further technical detail of mechanical systems. We can create a system using building blocks method, and then we can perform simulation on it. And also we can use animation to show. Get the display like this. For manipulator simulation, there is a demonstration program in Simulate. It is called Mac Robot. Well, I think there should be further notes. There are several Mac robots. This one is not with the VR, not with the virtual reality links. So what we need to find is another program, the robot manipulator with VR display, virtual reality display.
What command was it?
Sorry?
The command you used to
you mean that one? I'm not quite sure which version it starts with. Just you type some keywords and then press the tab key that you get. I'm not quite sure which version it starts. So you can get the different selections of it. So there is a 3-dimensional animation viewer which is used for virtual reality output. So we can perform simulation and you can visualize movement. But it may take some time for you to design the models, real world models. And then you can visualize the result.